Hello, my name is Noel D'Souza, and this is my video lab report for Lab 1 for Physics 2211. The purpose of this lab was to observe the motion of a real-life object and measure that, and then analyze the position of the object as it moves, and then build a computational model to represent this motion, and then compare the model against the actual motion of the object. So that's the video that I chose to record and analyze, and I ended up using a much smaller chunk of the video. I only used 10 frames to analyze the object, and you can see the tracker points that I placed along the object, and you can see the position time graphs over on the left along with the data points. So here is the code that I use to actually get the graph and get the data points from the data that I got from the tracker. So what it's going to do is first plot the position and time graph, and then plot the velocity time graph. Velocity is just going to remain constant because we're saying that the object isn't accelerating at all. So that's why the net force is also zero, because the object isn't accelerating. And then we're going to update the velocity. So the velocity is again going to stay the same because the net force is zero because the object is not accelerating at all. The position though will change. It's going to get updated by the velocity times the delta t, which for me was 0.33. We're going to update time so that this doesn't endlessly repeat. So the time's going to get updated by that delta t again. And then finally, we're going to print out the position of the position of the object and the time. And this is the final output of the program. So it created this graph, which is perfectly linear, of course, because the velocity is not updating at all. So this is exactly what I wanted. And then also it came with some data points and of course the velocity, but I chose not to show those here. Putting the data from the tracker and the graph that I created with the code together gives you this graph, which shows the comparison of the two. And you can see that they're very similar, they're very close together. The red is the one that I created with the code, and the blue is the graph that of the actual position of the object. And the little discrepancies in between could be due to any number of human error or inaccuracies in measurement or the way that the video was recorded. As for the post-lab questions, if I flipped the axis, then the positive y values would then become negative y values. But the actual result of the graph would not change because the physics remains the same. So it doesn't matter whether I'm treating the object going forward as positive y or negative y, it's still going to give me the same graph and the same results. It's just going to change some of the position numbers. And as far as being able to determine the number of forces acting on the object, you cannot determine this. Could be many forces that are all canceling out, so we're just going to treat the net force as zero. And finally, the limitations of this experiment. So there could be some human error when measuring, when plotting the tracker points, when taking the video. It could have not been perfectly straight. There's also the issue of frame rate. So frame rate doesn't perfectly capture how the object was actually moving. Like obviously there are moments that we didn't get to see. This is also treating this as one-dimensional motion when in reality it really wasn't one-dimensional motion, and it's not accounting for all the forces acting on the object. This has been my video report for my Physics 2211 very first lab. Thank you so much for watching.